Sophos XG Firewall version 18 introduces several network address translation or NAT enhancements. In this video, we will look at those enhancements, discuss the rationale, and demonstrate how administrators should create and deploy NAT rules. In previous versions of the Sophos XG Firewall, administrators assigned NAT policies within each firewall rule, selecting the appropriate predefined NAT policy. While this approach catered to the needs of many customers, the solution was deemed restrictive when deploying complex, advanced NAT configurations. In addition, administrators had no visibility of auto-created loopback and reflexive rules within the web user interface. Moving forward, Sophos XG Firewall version 18 decouples NAT from the firewall rule, thus allowing administrators additional flexibility as well as ease of management. To utilize the enhanced NAT features, administrators must deploy Sophos XG Firewall version 18 or above. Let's discuss the various types of NAT and the use cases associated with it. Source NAT, also known as SNAT. By default, the masquerade NAT policy translates the source address of outbound traffic using the public IP address assigned to the WAN interface, thus hiding the true internal source address of the internal network resource behind the public-facing WAN IP address. From Sophos XG Firewall version 18, administrators now have two options to SNAT the traffic to facilitate internet access. Option 1. Create a linked NAT rule. While Sophos has decoupled NAT from firewall rules, Sophos has implemented a differentiating linked NAT feature to grandfather existing deployments over to the new NAT architecture. Linked NAT allows customers who may wish not to use or manage separate NAT policies to apply inline source NAT translation to firewall rule matching criteria. In other words, administrators adding new LAN-to-WAN firewall rules may opt to create a linked NAT rule wherein the user can apply source translation attached to firewall matching criteria. Here is a network diagram showing the SNAT configuration. Port 1 is the LAN interface on the Sophos XG Firewall with the assigned IP address 172.16.16.16. All the LAN network devices are reachable through this interface. Port 6 is the internet-facing WAN interface assigned public IP address 1.90.80.50. Now let us look at how we can source NAT the LAN user's traffic to allow internet access. Navigate to Protect, Rules and Policies, and then select Add Firewall Rule. Enter the rule name, select the rule position, select Accept as the action, and select Enabled for the logging option. Since the user's traffic is originating from LAN, we will select the source zone as LAN. For the source network, we will create a new IP host object and configure the LAN network IP address 172.16.16.0 with a /24 subnet mask. We will now select the new IP host object as the source network. WAN should be selected for the destination zone as users will be accessing the internet. We will leave the destination network and services as any. We will now select Create Linked NAT Rule. Enter an appropriate name for the NAT rule. Select the position before selecting the masquerading policy as the translated source, ensuring traffic is NATed with the IP address configured on the WAN interface. Should traffic need to be source NATed with a different public IP address, a new IP host may be created and selected as the translated source. Where multiple WAN interfaces require source NATing with an alternative source IP address, we must enable the Override Source Translation option selecting the appropriate IP host for each WAN interface. Now click on the Save button, and the name of the linked NAT rule that is selected for this firewall rule will be displayed. Finally, we will click on the Firewall Rule Save button. As we can see, the linked NAT firewall rule has been configured successfully. To identify which linked NAT rule is associated with a firewall rule, simply hover the mouse cursor on the NAT icon at the right-hand side of the firewall rule. A pop-up message with the name of the linked NAT rule associated to the firewall rule is displayed. Additionally, administrators may click on the NAT Rules tab to view the newly created linked NAT rule along with its associated firewall rule ID. Option 2. Create a separate or independent source NAT rule, decoupled NAT. Administrators may create source NAT rules that work independently of a firewall rule, mapping traffic across multiple firewall rules to a single source NAT rule, thus reducing the network administrator's overhead and creating separate NAT rules for each firewall rule. Before we create our decoupled NAT rule, let's create a sample firewall rule. Navigate to Protect, click on Rules and Policies, and then click on Add Firewall Rule. Enter the rule name, select the rule position, action as accept, logging option enabled, and select the source zone as LAN. For source network, we will create a new IP host object and configure the LAN network IP address to be 172.16.16.0 with a /24 subnet mask. The destination zone should be selected as WAN because users will be accessing the internet, and we will keep the destination network and services as any. Finally, we will click on the Firewall Rule Save button. To create a source NAT rule, navigate to Protect, Rules and Policies, and then click on the NAT Rules tab. Now click on the Add NAT Rule button and specify an appropriate name for the NAT rule. Select the NAT rule position, and then in the original source section, we will select the same LAN network IP host object selected in the firewall rule. Select either the MASQ policy or IP host object and the translated source field to ensure traffic is NATed appropriately. We will keep the original destination as any and translated destination as original, as we do not want to NAT the destination IP of the traffic. We will keep the original service as any and translated service as original. In the interface matching criteria, we will select inbound interface as the port through which the traffic is initiated. Therefore, in this example, we will select the port 1 interface. Our intention is to send LAN traffic out to the internet via the WAN port. Therefore, we will select the port 6 interface as the outbound interface before clicking on the Save button. The second type of NAT is destination NAT, also known as DNAT. Where administrators require LAN or DMZ-based internal servers running on private IP address ranges to be visible from the public internet, the administrator may create a Destination Network Translation Rule, or DNAT rule. A DNAT rule will map inbound traffic terminating on a public IP address to a specific internal server IP address. I will use this network diagram to discuss DNAT configuration. Port 1 is the LAN interface of the Sophos XG Firewall with an assigned IP address 172.16.16.16. Our internal web server's IP address is 172.16.16.32 and is assigned to the LAN network, listening on HTTPS port 443. Port 6 is the alias interface created on the public-facing WAN interface, with the assigned IP address 1.90.85.2. I will demonstrate how we enable public to private IP mapping to publish the HTTPS web server service to the public internet via a DNAT rule. To make the DNAT rule creation easy for customers, a Server Access Assistant DNAT wizard is provided. So once we click on it, we need to first provide the internal IP address of the web server, either by selecting the already created IP host or creating one from the wizard page itself by just typing the IP address and the IP host name. The second step is to select the WAN interface or select the IP host. In this example, we will select the alias interface 1.90.85.2. The third step is to select the service that needs to be published for the internal server. We will select HTTPS. The fourth step is to select the hosts that should be allowed to access the web server. In this example, we will keep it as any. It will then show the summary of the configuration. The last step is to click the Save and Finish button. The wizard will create one DNAT, a loopback, and a reflexive NAT rule for the web server and create a firewall rule to allow the traffic from the WAN side. Alternatively, the user can also create the DNAT rule with advanced options. To start, we need to create a firewall rule to accept the HTTPS traffic on an alias interface. We will navigate to Protect, Rules and Policies, and then select Add Firewall Rule. Enter the rule name, select the rule position, select Accept as the action, and set the logging option to Enabled. We will select the source zone as WAN because the traffic is initiated from the external internet. For the source network, we will select Any, so that any internet user from any location may access the web server. In the Destination Zone dialog box, we will select LAN, as that is the location of the actual web server. In the Destination Network field, we will define the alias interface port 6, because the user's request traffic will arrive on the Sophos XG Firewall on its WAN interface before it is NATed to our physical web server. As we are only allowing HTTPS traffic to our server, we will define the HTTPS in the Services field before clicking on the Save button to save the firewall rule. Once the firewall rule is created, we need to create a DNAT rule to change the inbound traffic's original destination address. Navigate to Protect, Rules and Policies, and then click on the NAT Rules tab. Then click on the Add NAT Rule button before specifying an appropriate name for the NAT rule. Select the DNAT rule position while keeping the original source as Any and translated source as original, as we are not defining a source NAT rule. Select port 6 alias interface for the original destination, and we will create a new IP host object having the actual web server's IP address 172.16.16.32 for the translated destination before selecting it. We will select the original service as HTTPS, as our web server listens on HTTPS port 443, and we will keep the translated service section specified as original. For the interface matching criteria field, we will select inbound interface as the WAN port 6 and select Any as the outbound interface. The loopback policy allows internal LAN network hosts to access the internal web server via its external IP address configured on the alias interface. The reflexive policy translates the traffic initiated from the internal web server to the internet using the alias interface IP address as its source. The reflexive policy can be enabled or disabled based on the customer's requirements. Now click on the Save button and the DNAT rule is successfully configured. Let's take a look at another scenario. whereas the customer has deployed multiple servers on the LAN network with corresponding IP addresses 172.16.16.41, 172.16.16.42, and 172.16.16.43. Here we have a requirement to load balanced traffic initiated from the WAN between the three servers. In this scenario, the firewall rule configuration would remain the same as shown in the previous DNAT single web server scenario. For the DNAT rule, navigate to Protect, Rules and Policies, and then click on the NAT Rules tab. Now select the Add NAT Rule button before giving the NAT rule an appropriate name, and specify the rule position. In this example, we do not intend to source NAT the traffic. Therefore, we will keep the original source as any and translated source as original. For the original destination, we will select the alias interface, and then we will create a new IP host object having the list of web server IP addresses 172.16.16.41, 172.16.16.42, and 172.16.16.43 before selecting it. We will select the original service as HTTPS as the web servers listen on HTTPS, and we will keep the translated service section as original. In the interface matching criteria field, we will select the inbound interface as the WAN port, and select the outbound interface as any. Under the advanced settings, administrators may choose one of several load balancing methods. Round robin. Traffic is distributed equally between all the web servers. First alive. The incoming requests would be directed to the first IP address in the list. If that web server fails, the request would be forwarded to the next server in line. Random. The requests are directed randomly to the servers with equal load distribution. Sticky IP. The traffic from a specific source would be forwarded to a specific web server. This method is useful where administrators want specific client requests to be processed by a designated server. One-to-one. NAT load balancing. NAT load balancing maps multiple public IP address traffic with multiple internal LAN server hosts, one-to-one relation. The health check field allows administrators to select a method of polling in order to establish whether a web server is alive. Should polling fail, the XG Firewall will assume the server is not reachable and forward traffic to the next available web server. In this example, we will select ICMP as the health check polling method. Now click the Save button to save the DNAT configuration. The third type of NAT is port address translation, also known as PAT. Let's take a look at an example network diagram. Port 1 is configured as our LAN interface, IP address 172.16.16.16. Our internal web server IP address 172.16.16.32 belongs to the LAN network and listens on the TCP port 8999. Port 6 is an alias interface, public IP address 1.90.85.2, created on the WAN interface. I will now demonstrate public to private IP mapping along with port address translation to accept inbound HTTPS port 443 requests, while forwarding the traffic to the real internal web server listening on TCP port 8999. This action will make the web server accessible from internet-based clients via the NAT rule. First, we need to create a firewall rule to accept the HTTPS traffic on an alias interface. Navigate to Protect, Rules and Policies, and select Add Firewall Rule. Enter the rule name, select the rule position, select Accept as the action, and the logging option should be enabled. Select WAN as the source zone as the traffic is initiated from the Internet. For source network, select Any. This will allow any user from any location to access the web server. LAN should be selected as the destination zone because that is where the web server is located. Alias interface port 6 should be selected for the destination network because the user's request traffic arrives at the XG's WAN interface before it is NATed. Since we only need to allow HTTPS traffic, we will select the HTTPS under Services before clicking on Save. Once the firewall rule is created, we need to create a NAT rule to translate the original service, HTTPS port 443 to custom HTTPS TCP service on port 8999. Navigate to Protect, Rules and Policies, and select the NAT Rules tab. Now select the Add NAT Rule button and type in an appropriate name for the NAT rule. Select the position, keep the original source as Any, and translated source as original because we do not want to source NAT the traffic. For the original destination, we will select the alias interface port 6. For the translated destination, we will create a new IP host object, IP address 172.16.16.32 for our LAN-based web server and select it. We will select the original service as HTTPS. In the translated service, we will create a new custom service having the protocol selected as TCP and the destination port as 8999 before selecting it. For the interface matching criteria, we will select WAN port 6 as the inbound interface and select Any for the outbound interface. Click the Save button to complete the port address translation NAT rule. Now let's discuss the Sophos XG Firewall version 17 to version 18 migration. When migrating from Sophos XG Firewall version 17 to version 18, administrators are likely to see many linked NAT rules created during the migration process. Many linked NAT rules may have similar source NAT translation settings masquerade selected in the translated source section. This is because Sophos cannot consolidate optimize the linked NAT rules automatically, as there may be some version 17 deployments in the field without any NAT policy selected in the firewall rules. Therefore, post-migration, administrators may decide to manually optimize the NAT table by creating single source translation NAT rules that take care of translating the source for multiple firewall rules. For example, administrators may create a single masquerading source NAT rule at the bottom of the NAT rule list, deleting multiple linked NAT rules auto-created during migration. For business application rules, DNAT, separate NAT and firewall rules will be auto-created with business application rule matching criteria. As shown in this example, firewall rules in version 17 had the NAT policy bound to it. Here's an example of a Sophos XG Firewall version 17 configuration migrated to version 18. As we can see, the rules are migrated successfully, and for every SNAT firewall rule, there is an associated linked NAT rule created automatically. The business application rules are migrated as firewall rules, as well as the associated NAT rules. These measures ensure that the migration process should not break any existing NAT-dependent XG functionality as a direct result of the migration process. Let's take a look at the caveats associated with the NAT enhancements in Sophos XG Firewall version 18. If a firewall rule is deleted, the associated linked NAT rule will be auto-deleted from the NAT rule table. Once delinked, a linked NAT rule cannot be linked again to any other firewall rule. Linked NAT functionality for destination translation scenarios are not supported. The rule order for new NAT functionality works in the same way as firewall rules, matched based on a first match basis, in the order they appear, top to bottom. As the first match is applied, administrators must ensure that specific rules are ordered before more general rules, or the specific rules might not be applied as desired. While creating a firewall rule for DNAT traffic, please ensure you configure post-natted zone or final destination zone as the destination zone, the pre-natted IP address as the destination network and in the DNAT rule. Select the inbound interface configured as the WAN port traffic interface with the outbound interface configured as any. There are no changes to configure NAT and overlapping subnet scenarios for IPsec site-to-site VPN and system-generated traffic. To configure NAT for overlapping subnet, navigate to the IPsec VPN configuration settings page. To configure NAT for system-generated traffic, use CLI via the Set Advanced command. NAT rules are solely responsible for IP and/or port translation. Administrators must create relevant firewall rules for the traffic to flow in and out successfully. There are additional NAT enhancements introduced in Sophos XG Firewall version 18. In NAT rules, there is a usage indication column at the right-hand side that shows the number of connections that a NAT rule has processed to perform NAT translation. We can also reset the usage count to 0 from the ellipsis icon and then click on the Reset Usage Count option. We can also apply various filters for the NAT rules, such as selecting the Hide Linked NAT Rule option to see only the independent NAT rules from the list. We can also select the type of NAT rule, such as Destination NAT, Source NAT, or Service-Based NAT. We can also filter the NAT list by its state, such as unused, disabled, changed, and new. We can also simply enter the NAT ID in the text box area to filter a specific NAT rule. This is useful for troubleshooting purposes. By clicking on the Reset Filter option, it will remove the existing filters and will show all the NAT rules in the list again. Let's now take a look at how we can troubleshoot some NAT-related issues. In our example, we are using a client computer IP address 172.16.16.32 with gateway IP of 172.16.16.16 that is configured on an XG LAN port. We can use the TCP dump utility from the web UI itself by navigating to Diagnostics, Packet Capture, and then click on the Configure button. In this example, we are trying to ping 8.8.8.8 IP. So we enter the BPF string as host 8.8.8.8 and ICMP. Enable the toggle switch in order to see the live ICMP request reply traffic along with the NAT ID associated to that traffic flow. To view the configuration of the respective NAT ID, we can click on Rules and Policies, click on the NAT Rules tab, and simply enter the NAT ID into the text box to see the actual NAT rule being matched for that traffic. Administrators may use the log viewer, which will open a new browser window. Ensure Firewall component has been selected from the drop-down list. This will show log data of all the traffic that is passing via the XG Firewall. Administrators may filter out specific traffic by entering the IP address 8.8.8.8 in the search text box. As we can see, the output will detail the firewall rule ID as well as the associated NAT ID for that traffic. Click on the NAT ID and then click on the Filter NAT Rule option so that it will automatically show that specific NAT rule once the log viewer is minimized. Sophos XG Firewall version 18 Enterprise NAT features can be utilized to configure both common and/or advanced NATing scenarios, providing simplicity unifying NAT rules relating to multiple firewall rules. We hope you liked this video and thank you for watching.